Okay, then let's talk about the 12.4, the phase change. Before beginning, we have to know just the basic knowledge. We have some times for just note taking or just repeat.
The times to note taking.
Okay, maybe a lot of people already know about this. We have seen it before. And let's talk about we have been talking about this already. Increase of temperature, we can also increase of kinetic energy. And this is really important in this chapter. Heat is the transfer of energy from an object at a higher temperature to an object at a lower temperature. In other words, the heat goes from higher temperature to a lower temperature. Okay? And then maybe we're concentrate about just melting, freezing, and evaporation. Okay. And firstly, we're talking about melting and freezing. Before talking about the concept of melting point, I'm going to talk about the process of melting of ice. First, the heat of ice increase because of the surroundings heat, which is higher temperature. In other words, the surroundings higher temperature go to the ice, which is lower temperature, and it makes kinetic energy of ice increasing. And then when there's enough kinetic energy, and it breaks hydrogen bond, which is IMF, between water molecules, and that consists of ice, and finally it becomes the water. And so the melting point is a temperature at which the force holding the crystal lattice, which is intermolecular force and ice, are broken and it becomes a liquid. And then the freezing point is pretty similar. It is a temperature at which it is just reverse. It is temperature at which a liquid is converted into a crystalline solid. And freezing point occurs when heat flows from water to surrounding. It means water has higher temperature and surrounding has lower temperature. So heat goes from the water to the surrounding. So water loses kinetic energy and it makes ice.
Mm-hmm.
Okay. 인정? 인정. Okay, next is just vaporization. Before know about the concept of vaporization, we have to know the difference between vaporization and evaporation. Vaporization is just, everybody knows that the process by which a liquid changes to a vapor, and evaporation is just a kind of vaporization. Okay. But it occurs only at the surface of a liquid, maybe the top of the liquid. And the principle of vaporization is similar with melting also. Enough kinetic energy breaks intermolecular force between compounds in water and makes them gas states. Okay. And now we're going to talk about, we'll watch about some graph. It's called energy distribution of molecules in a liquid. It is pretty tricky, but let's learn. In fact, every water does not start to vaporization. Maybe only few molecules of water become vaporized. And this graph shows it. And this is the most of water, and just like the speaker, maybe this part just under, and maybe they do not start vaporization, but really small amount of water, maybe which is the top of the liquid, which is on surface, and they start to vaporization through the high kinetic energy. Okay. And now let's go talk about another some tricky one called the vapor pressure. Vapor in a closed container, the pressure exerted by a vapor of a liquid is called vapor pressure. It is kind of the difficult ones in this chapter. When we up to the container, the vapor from the liquid just go up from the container, and it does not affect to the H2O in liquid. But when we close the container, H2O, the water vapor cannot go out, and it disturbs another water molecule's vaporization. If some water molecule in liquid tries to go to vapor, but the vapor pressure puts it down and forbidding any more vaporization, and this is called vapor pressure. Okay. In fact, in real times we have not seen the vapor pressure in real life, but instead of the vapor pressure, we already have another pressure called atmospheric pressure. It is just pretty similar with vapor pressure. The red one is just another pressure in our air, gas pressure. And if there are just few number of molecules tries to go up as a water vapor, another atmospheric pressure puts them down, and the vaporization ceases. However, at the high temperature, the more water molecules try to go up, and it defeats the atmospheric pressure and tries to go out. So the boiling point is the temperature at which the vapor pressure of a liquid equals the atmospheric pressure. Okay. And then we're already almost done. And the last one is called phase diagram. Maybe some people know that. A phase diagram is a graph of pressure versus temperature that shows on which phase substance will exist under different conditions of temperature and pressure. For example, in CO2, when we make high pressure, the gas can be solid or gas can be liquid. Or in the liquid state of CO2, if we lower the temperature, it can be solid. And the phase diagram represents them. And we have to know that every phase diagram of each substance is all different. For example, the carbon graphite, which is in Korean 석탄, becomes a diamond through the high pressure, but other substance does not. And then there is another concept called the triple point and the phase diagram. The triple point is a point on a phase diagram that represents the temperature and pressure at which all three phases of a substance can coexist. Maybe we can't ignore all of this. We have to just concentrate about this one. In here, there can be liquid state, vapor state, or solid state, all of three. In other words, there can be occur in freezing, boiling, vaporization, anything. Okay? And yeah, that's all.